This is our second weekly walkthrough video, and it's to prepare us for the Algebra 2 Regents. So this one, we're going to go through a couple logarithms and review some of the logarithm properties, as well as an inverse function. So let's look at number one. The first question says, which of the following is equivalent to log, and it's x cubed over the cube root of y. And looking at my answers, I can tell that one, I'm going to have to get rid of that radical, the cube root, at some point. And also, I have a condensed logarithm that I'm going to expand. And that's indicated by the fact that it's in a quotient. So I'm going to use my quotient property. And the quotient property is going to allow me to subtract those logarithms with the same base. So let's try that. So the first thing I'm going to do is I'm just going to rewrite this so I can see what's happening. And I have log of x cubed over the cubed root of y. And because they're in a quotient and we have the one base that we're working with, I can use the quotient property and I can rewrite them as log to x cubed minus log cube root of y. I think the next thing I would like to do is to convert my radical over here, my cube root, into y to the 1/3. And we know that because when it's power over root, and the power that's on our y there is actually a 1, and then the root sits on the radical. So that's how we've converted that cube root to that. Now that I have it in the subtraction, I'm going to take the power rule and I'll just highlight right here. That exponent is going to come down to the front for both of them, right in front of the log. So my new answer becomes 3 log of x minus 1/3 log of y. And it's understood that these are in a base 10 because when you have a logarithm that does not have a base listed, it's assumed that it's base 10. And at this point, this answer equals number 3. So I have solved that and expanded that logarithm. Let's go on to number 2. Well, before I do that, I want to go through my self-assessment and see how well I knew that. If not, if I felt like I struggled a little bit on that, might want to review the quotient property of logarithms as well as the power rules for logarithms. So let's go on to number 2. Okay, we're on to question number 2, and it says the expression 4 log of x minus 1/2 log of y plus 3 log of z can be rewritten equivalently as, and this is already the expanded form of the logarithm. I'm going to want to condense these logarithms and remind myself that when I see addition, it's going to remind me to multiply those. And if I see subtraction, it's going to be to use my quotient rule. The other thing I see is that I do have scalar multipliers. I have numbers in front of my logs, and those I'm going to move them inside as powers. And I'm also going to make certain that all of my logs are the same base because that's the only way I could use rules. So let's start working on the problem. So I have, for the first one, 4 log of x, and then I have minus 1/2 log of y, and then I have plus 3 log of z. I'm going to move my addition ones together and my subtraction one on the end. And now I'm going to take my scalar multipliers and move them inside as powers. In other words, I'm going to take the numbers that are in front of it and I'm going to move them up as exponents. doing that, I'm going to have log of x to the fourth plus log of z to the third minus log of y to the 1/2. These ones right here, because I'm adding them, are going to be multiplied together. So that can be rewritten as log of x to the fourth times z to the third. And then I have log minus log y to the 1/2. Another way that I could say y to the 1/2 is the square root of y. So this can be rewritten as the square root of y. So I now have log of x to the fourth, z to the third, and with that subtraction, I can use my quotient property of logarithms, and I'm going to rewrite this as log of x to the fourth, z to the third, over the square root of y. And I see that that is answer number 1. So we're done. We're on to number 3, and number 3 is solve log of the quantity x plus 3 plus log of x equals 1. And I've already circled my plus sign there because it's going to remind me that I'm going to be doing the product rule. So I could rewrite this as log of quantity x plus 3 times x. I'm getting that because of this right here becoming a product. And that is all equal to 1. The next thing I'm going to do is I'm going to distribute out the x to each the x and the positive 3. So I get log of x squared plus 3x, and that's all equal to 1. Next, I'm going to remember that even though there's no base written, there really is the base of log base 10. Whenever you don't see a base number written there next to the log, we assume that it means log to the base 10. So I've rewritten that as log to the base 10 of quantity x squared plus 3x equals 1. Then I'm remembering what logarithms really mean, which is giving me the exponent answer. So this means the same as 10 to the first power equals x squared plus 3x. 10 to the first power is just 10 equals x squared plus 3x. If I subtract the 10, I get x squared plus 3x minus 10 equals 0. However, my answers are not polynomials, which means I'm going to have to factor this out and find the solution to this. So factoring it out, I know that I'm going to have an x for the first part. I'm going to look at my negative 10 and think of the factors. I can do 1 and 10, 2 and 5. It's going to be one of those, but it's got to give me a positive 3x. So I'm going to pick the 5 and the 2 and make the 5 a positive and the 2 a negative. So I have x minus 2 and x plus 5 equals 0. If I set each of those equal to 0, I can see that I'm going to have a solution of x plus 2, or x equals negative 5. Another way would have been for me to have looked at each of these factors and thought, if my answer is 0, one of those has to be 0, which means that my x would either have to be 2, because 2 minus 2 would give me a 0 there, or my x would have to be a negative 5 because that would have given me negative 5 plus 5, which is also 0. So one of those would have been 0. Looking at my answers, I can see that 10 is not an answer I'm going to want, and 7 is not. I do see my answer here, but before I choose A, we need to talk about my solutions and see if they're valid for a logarithm. Let's look at x equals negative 5. If x was going to equal negative 5, again, we're looking at x equals negative 5. If I plugged that back into my original equation, it's essentially saying then that I could do the log of negative 5. One of the problems with that is, let's do a logarithm that we know. If I did log to the base 3 of negative 9 equals some number. And if I did log to the base 3 of 9 equals some number. With the rules of logarithms, I'm saying that gives me an exponent answer, gives me an exponent answer. So it's the same as saying 3 to some power equals negative 9, and 3 to some power equals positive 9. For the lower one here, I'm immediately thinking, oh, that power would be 2, because 3 squared equals 9. However, at the top with the negative 9, I can't think of a power that's going to give me a negative 9. If I think of a negative exponent like negative 2, 3 to the negative 2 is going to give me 1/9. I'm not going to be able to take a logarithm of a negative number because it's not going to be valid for my expression. I can't come up with an exponent. It's undefined. So I can't take log of negative 5, which means that negative 5 is not a solution to the problem. So 2 is my only solution, which is C. That was a little tricky, but now that I remember the rules of logarithms, it makes a little bit more sense. Okay, we're going to try question number 4. We're on to question 4, and question 4 says, which expression is not a solution to the equation 2 to the t power equals the square root of 10? So I'm going to underline not because I'm looking for the one that is false. And I notice they're all logarithms, so I think the first thing I want to do is get my expression into a logarithm. So I'm going to rewrite it as 2 to the t power equals, and I'm going to rewrite that 10 to 10 to the 1/2 to see if that helps me out a little bit. Then I'm going to take the log of both sides. So I have log of 2 to the t power equals log 10 to the 1/2 power. And then I'm going to use my power rule to bring those exponents down to the front. So I have t log to the base 10 of 2 equals 1/2 log to the base 10. I'm going to divide log to the base 10 of 2, both sides, log to the base 10 of 2. These two are going to cancel out. So this leaves me with t equals 1/2 log to the base 10 over log to the base 10 of 10 over log to the base 10 of 2. Which are none of my answers, but it looks very similar to 1. So let me see if there's a way that I could rearrange it. And I'm immediately thinking of my change of base formula. I can use my change of base formula for this part right here and say that t equals 1/2, and then change of base formula says I take the bottom becomes the base, but a little alliteration there, bottom becomes the base, and the one in the numerator becomes that number there. That does look like number 1. So that means number 1 does work. So it's not the one I want to cross out because I'm looking for the one that would not work. Looking at answer number 2, I can see that I can manipulate this a little bit more, the answer I just came up with. And I could take that 1/2, put it up here as an exponent, and it can become log to the base 2 of 10 to the 1/2 power, or log to the base 2 square root of 10. That answer right there is number 2, which means that number 2 works and is not the answer because I'm trying to find what is not a solution to the equation. I'm still left with 2 answers, and the one thing that I notice in each of the remaining answers is there's a 4 in them. So I'm looking at my original expression thinking, how could I get a 4 out of that? It's almost like I need to square or double my 2. So I'm going to go back to my original expression for a minute and see if I can do something with that. So I had 2 to the t equals the square root of 10. One of my thoughts is solving this first without logarithms and just squaring both sides. That's then going to give me 2 to the t squared equals 10. I know that this then can be 2 to the 2t equals 10, and I can then say 2 squared to the t power equals 10, which is 4 to the t power equals 10. So it looks like I'm on the right track, but now I have to remember which one of those is the correct way to write it. So I'm going to write an expression that I know, and it will help guide me to make certain that I'm putting it in the right place. So one of the things I know is, again, this is just for reference, log to the base 10 of 100 equals 2. So if I follow that same pattern, I know that 10 squared equals 100. So I'm going to use that to help me rewrite that into the logarithm way. So I end up with log to the base 4, because that is the base of my exponent, of 10 equals t, because logarithms, remember, are giving us that exponent answer. And now that I have that rewritten, that does match up with number 3, which means that number 3 also works and can't be my answer. So the original answer to my question is which expression is not a solution to the equation. The one that is not a solution is the last one. And I'm done with that question. That was a tough one. Let's go on to number 5. So before we go on to number 5, I know that that one seemed a little bit harder, and sometimes we get these challenging ones, and that took us pulling from a lot of knowledge. But even if you were discouraged getting to the end of it and wondering, how would I have figured that all out, you now have a little bit more knowledge than when you first started. So try to keep building on that and realize that this will become a lot easier the more practice you have. Honestly, practicing a lot of these and getting used to manipulating them and rewriting them is so helpful. Okay, let's go on to number 5. We're on to number 5, which is saying, what is the inverse of y equals 2 to the x? And when we do inverse functions, the first thing we normally do is we switch the x and the y. So we end up with x equals 2 to the y. Problem is, we need to have our inverse function now say y equals. And we don't have this in a y equals, which is why we use logarithms, is to get that exponent down. It's the only way we can undo this. So I'm just going to swap sides for a second so it's easier to see. And I end up with 2 to the y equals x. And again, this is sometimes where I'll pick an expression that I know just to make it easier for myself. So, for example, off to the side, I might just say, I know log to the base 10 of 100 is 2, or 10 squared equals 100. That's just to remind myself kind of how they relate to each other. So looking at my 2 to the y equals x, I know that that 2 is really representing my base, and I can see that in my 10 squared over here. So I'm going to write log to the base 2 of, and the number that I'm putting next to that is at 100. So in other words, that's going to be my x equals, and then my exponent is always my answer because logarithms are giving me that exponent answer. So I'm going to see if this is one of the answers shown there, because now I have this in y equals, and I have y equals log to the base 2 of x. That is letter A. And I'm done. So there were a lot of different properties and manipulations of these logarithms that we did in these 5 problems. This is a good time to go through the self-assessment. You might not need to relearn all the properties of logarithms or focus on all of them. Maybe there's just a couple that you're struggling with. Maybe you just need to keep rewriting logarithms and exponents and being able to go back and forth and having maybe a base one that works for you. Maybe 3 squared equals 9, and being able to go back and forth between logarithms and it as an exponential. So hopefully this helped a little bit, and we'll keep practicing and trying our best. Okay, thanks. Bye.